Hello students, I hope that you are good, well and fine. In today's session, we will be continuing the solution of NCERT exercise 6.2 which in previous session we just have covered the 1 to 7 problems. Now we will be trying to cover the remaining problems. Okay, so let's see the first or the 8th problem. Okay, 8th problem from this NCERT exercise 6.2 is saying that find the values of x for which y is what? As you can see, for which y x multiply with x minus 2 whole square is an increasing function. Okay, simple. This means what? That you have to first find the derivative of this. So finding the derivative, what you will have, finding the derivative, what you will get? You will get 2 times of x multiply with x minus 2. Okay, and then multiply with the inside thing derivative. The inside thing derivative will be x minus 2 plus x, this thing. This means 2x minus 2. Okay, this means 2x minus 2. So you can also rewrite or convert this. So 2x minus 2 means take 2 common, you will have x minus 1. Yes, you will have x minus 1 and 2 will be multiplied with this thing. So it will become 4. Okay, simple. The simple thing is happening. Okay, now the f prime is your this. Okay, so as you can see, the signs are depending on this thing, this expression and this expression. So let me just first of all break my whole real number into intervals, some intervals. So from those intervals I can get what, when I will be getting my positive, when I will be getting my negative f prime. So quite simple. So as you can see, for x you can put 0, for this expression you can put 2, and from this you can put 1. So you have 3.021. Now using 0 to 1, which is your least value? Least is 0. So you can take least value to the minus infinity to the least value. Okay, one interval will be minus infinity to the least value. And what is your maximum value? Then you can take maximum value to the infinity. Okay, this is every time you have to follow this thing, that minus infinity to the least values and maximum value to the infinity. Now you can form the in between interval also, 0 to 1 interval and 1 to 2 interval. So 0 to 1, 1 to 2. So this means you will have 4 intervals, and in those 4 intervals the sign will be like what? So let me just see. So if you are in this minus infinity to 0 interval, then what will happen? Observe that if x is negative, this means this value is negative. Yes, this value is negative, this value is negative. Negative plus multiply will give you positive, but this negative will give you negative. So this means in total you will get negative. Okay, in total you will get what? Negative. So in minus infinity to 0 it will be decreasing. Okay, now what interval? So 1 to 2 interval. See, so if your value is from 1 to 2, in between 1 to 2, this will be positive. Okay, this will be what? It is less than 2, the value of x is less than 2, this means negative, and this will be positive. So positive multiply this positive will give you positive, but positive multiply negative will give you negative. So in total you are getting negative. So this means your y prime of the f dash is negative in both of these intervals. So that's why it is decreasing in these specific intervals. Okay, now if you consider what your interval 0 to 1, so 0 to 1 will give you what? Just observe, you are picking your number 0 to 1, x is in between 0 to 1, this is positive. If 0 to 1 means this is negative, 0 to 1 means this is also going to negative. So negative gives you positive. Now this positive multiply with this positive will give you positive. That's why f prime will be positive or y prime will be positive. Okay, so in 1 to 2 your interval, what? In 0 to 1, this is positive, This means increasing. What about 2 to infinity? Observe. Just you have to observe things. Okay. Now 2 to infinity, you will see that this is positive. This will be positive, and this also will be positive. So this means positive multiply with positive multiply with positive, in total you will get positive. So this means increasing. So in this interval you will have increasing, strictly increasing. Clear? I hope that it is clear to you. What is happening? We have to just find the first order derivative, then find these points where we can form our intervals. Okay. Now the ninth thing we have to prove. So y is equals to 4 sin theta by divided by 2 plus cos theta minus theta is an increasing function in this interval. So let's see how you are going to. First of all, the first thing is find the derivative. The derivative will be the quotient rule I will be using. So it will be just 1. So 1. Now the whole square of this thing, the denominator square. So this, the denominator will be untouched. Now the numerator derivative will be 4 cos theta. So 4 cos theta. Now minus of numerator will be untouched, like 4 sin theta. Okay, now the derivative of the denominator, it will be minus of sin theta. So sin theta. Now simplify it. What you will have? 8 cos theta plus 4 cos square theta. 8 cos theta plus 4 cos square theta, and this will be plus 4 sin square theta. Add these terms, you will have 4 multiply cos square theta plus sin square theta. This will become just 1. So it will be 4. Okay. Simple. Now 8 cos theta, now take 4 common, then it will be what? 2 cos theta plus, if you take 4 common, then you will have 4 multiply with 4 cos theta 2 cos theta plus 1. Simple. Then minus 1, then put it equals to 0. If whenever you put dy equals to 0, you will find that some points, and those points will be your critical points, where you will, those points will help you to find the intervals where it is increasing and where it is decreasing. So putting this dy equals to 0 equal to dy equals to dx equals to 0, then it will be what? This expression put. Okay, so it will be equals to 1. This multiply, cross multiply, you will have 8 cos theta plus 4 is equals to 2 plus cos theta whole square. This whole square, if you want to expand, you will get a square plus b square plus 2ab. 2ab means 4 cos theta. Now as you can see, this and this will give you minus 4 cos theta. So cos square theta minus 4 theta minus 4 cos theta. Okay. Clear? And this 4 will be cancelled. So you will have this. Now take cos theta common. You will have cos theta multiply with cos theta minus 4 is equals to 0. So this will give you cos theta is equals to 0 and cos theta is equals to 4. This cannot be happen. You know the cos theta max to max value can give 1. Yes. Okay. So this means, but this can happen that theta is equals to 0. Now we are talking about 0 to pi by 2 interval, and theta can give only 0 when it is pi by 2. If we are talking about in this space, only in this interval 0 to pi. Okay, clear? So at pi by 2 cos theta is 0. Okay, so we have pi by 2. So we can have what? So you can have only what interval? You can have 0 to pi by 2 interval. Okay, so if you try to see in 0 to pi by 2 interval, cos is what? If you try to see by using the graph 0 to pi by 2, this is what? The positive output. This means cos theta is positive. Okay, this means what? This cos theta is positive, and this thing is also going to be positive. As you can see, 4 minus cos theta, and we know the max to max it can get up to 1. So 4 minus cos theta will also be a positive. So that's what it is written over here. So this is positive, and denominator thing is already positive. So this means the whole expression becomes positive when we are talking about in interval 0 to pi by 2. So that's why dy over dx is positive. So this means what? Y is strictly increasing in the interval 0 to pi open interval. Okay, also it is given what if you remember the theorem, when it is given that at endpoints it is continuous, if it is continuous at endpoints, then we can also say that y is increasing in this interval, closed interval 0 to pi. Okay, but in open interval it is increasing, strictly increasing. In closed interval it is what? Just increasing. Okay, I hope that it is clear. Okay, let us move to the next problem, problem number 10. So we have to prove that the logarithmic function is increasing function from 0 to infinity. The domain is 0 to infinity. The derivative is 1 by x. Okay, the derivative is, we are taking f(x) is log x. This means f is log x, and the derivative you all know 1 by x. And you all know when x is positive, the domain is positive, as you can see. So this means by just seeing, this will also be positive. So in this domain my f prime x is positive. So this means f dash x is always positive in this domain. This means fx is strictly increasing in this interval 0 to infinity open interval. Okay. Now let us move to the 11th problem. 11th problem is saying that fx is this function, this expression, this rule. It is neither strictly increasing nor decreasing. In -1 to 1, we are talking about in -1 to 1. Okay, so as you can see, the derivative of this will be what? 2x. Okay, derivative will be 2x minus 1. Okay, f dash, and you know it will be positive when? It will be positive if x is greater than half, and it will be negative, f prime will be negative when x is less than half. X is less than half. So this means if you see that 1 to 2, going from 1 to half to 1, in this interval my graph is increasing, but in -1 to half interval my graph is decreasing. So that's why it is neither increasing nor decreasing. Okay, as you can also see that in half to 1 it is increasing, but in -1 to half it is decreasing. Simple. Okay, that's why it is nor decreasing nor increasing. Okay, let us move to the next problem, problem number 12. Now problem 12 says that which of the following functions are decreasing on this interval, decreasing on this interval. Okay, let's see. We want open interval 0 to pi. Okay, let's see 0 to pi open interval. If you want to see from the graph, you can also see from the graph. If you want to see from the derivative, you can also see from the derivative. Let me just directly give you the graph method. So cos x is, you all know this. So it is decreasing on 0 to pi. Yes, 0 to pi cos x. Okay. Now what about cos 2x? So cos 2x will be, as you can see. So let me just remove it. So let me just graph it. Okay. So for cos x, this is for cos x, cos x. This is for cos x graph. Okay. Clear? Cos x graph. This point is pi by 2. Okay. Yes. This point is pi by 2. Clear? Okay. Now cos 2x graph, this is cos x graph. Okay, the pencil is not working, so we will see the normal approach. Okay, clear? So the derivative, obviously the approach is by using the concept of derivative. So first derivative of a part will be minus sin x, and minus sin x will give you what? The sin x in interval 0 to pi by 2 is always positive and positive, but the minus sin x will be negative. So that's why it is decreasing. Okay, it is decreasing. The first thing is decreasing. If you try to see it by graph, you can directly see it. This will be minus 2 sin 2x. This will be minus 2 sin 2x. Now Now you all know x belongs to what? 0 to pi by 2. So this means 2x belongs to 0 to pi, and we know that sine 0 to pi will be what? Positive. So this means this will be positive. This means minus multiply with positive will give you negative. So this means still decreasing in 0 to pi by 2. Okay, decreasing in 0 to pi by 2. Clear? Decreasing in 0 to pi by 2. Okay. Okay. Now what about c? C is cos 3x, so it will be minus 3 sine 3x. So derivative is minus 3 sine 3x. Okay, you know what you know is that sine 3x, now x belongs to 0 to pi, x belongs to 0 to pi, 0 to pi by 2. This means what will happen? This means what will happen? You all know. First thing, that if you observe, okay, so if you observe what observation, that put it equals to 0, then the point you will get will be your point which helps you to define your interval, in which interval you are going to take the positive things and you are going to take the negative output for f prime. So let's see. So putting equals to 0, it will give you 3x is equals to pi, and what? 3x is equals to 0 also. So this means x is equals to 0, but the domain we do not have x is equals to 0, but in domain x can be pi by 3. Yes, so this that's why we can easily take this 3x is equals to pi. This means x is equals to pi by 3. This means pi by 3 is indeed it belongs to this interval. So that means x is equals to pi by 3. So take 0 to pi by 3 interval first. So taking 0 to pi by 3, taking 0 to pi by 3, this is positive. This means the whole thing is negative. So this means in this interval my graph is decreasing. At 0 to pi by 3 my graph is decreasing. At 0 to pi by 3 my graph is decreasing. Why? I have already told you, because f prime is minus 3 times sine 3x, and we know that sine 3x, just sine 3x in this interval is positive, but positive multiply with minus will be give you negative. So that's why. Okay, so it will be decreasing. Now what about pi by 3 to pi by 2? If you observe pi by 3 to pi by 2, the sine x is still positive. The sine x is still positive. Sine 3x is still positive. So this means positive multiply with negative will give you negative. Okay, clear? The sine x, if you multiply, once again let me see. So sine, we are having what? Sine 3x, and x is belonging to where to where? X belongs to pi by 3 to 2 pi. Okay, pi by 3 to pi by 2. This means what? 3x must be belongs to where to where? 3x must be pi to what? 3 pi by 2. Pi to what? 3 pi by 2. 3 pi by 2. Okay, this means sine 3x, if 3x belongs to in this interval, this is 3. Okay, 3 pi. Okay, so I'm not able to write. So 3x is equals to what? Pi to 3 pi by 2. Okay, 3 pi by 2. Simple. Okay, now what? Now sine 3x will be what? Negative. This quadrant is what? This is what? Third quadrant. In third quadrant, you all know the sign gives negative output. So this will be some negative value, negative value. So negative means negative multiply negative will give you positive. So that's why it is written over here. It will be positive. But here at 0 to 3, you found out that your f prime is negative, but in this interval, your f prime is positive. So this means what? This means what? This is neither increasing nor decreasing. This is what it is written over here. Nor increasing nor decreasing. Clear? Okay. Now the fourth thing. Now the fourth part is tan. So tan derivative is sec square. You all know sec square. This will always be positive. Yes, in 0 to pi interval, this will give you positive output. Yes, so this means it is increasing. But the question was, we have to find the strictly decreasing function in 0 to pi by 2 open interval. So we got only option A and option B, which is cos x and cos 2x. Clear? Cos x and cos 2x. I hope it is clear to you. Okay. Let us move to the next problem number 13. So problem 13 says that find the interval, okay, where it is decreasing. This expression. So x power 100 plus sin x minus 1. So derivate it, what you will get? 100 multiply with x power 99 plus cos x. So you will get 100 multiply with x power 99. Okay, x power 99. Okay, as you can see. So 100 multiplied with x power 99 plus cos x. Now you all know what you know. First of all, you have to find the interval in which. So observe. So first option is 0 to 1. So 0 to 1 means cos x is positive, gives you output positive, and in this interval this is also positive. So it will be increasing in this interval. So we do not want that. We want our function to be decreasing. Okay. Now in second option, pi by 2 to pi interval, open interval. In pi by 2 to pi, if you draw the graph of cos, the graph of cos from pi by 2 to pi is decreasing in this interval. Yes, decreasing. So this means it is negative value. The output is negative. So negative. Okay. So negative. Now, but this will be what? Positive. But, and also one thing is very clear, this will be very much greater than this. As you can see. Yes. Yes. So this means it's still positive. Why we said that it is greater than cos x? Because you know the cos x will be restricted to where as it is negative. First of all, this value will be negative, obviously, and this value will be what? Positive. Yes, this value will be positive. So positive will also be the greater than the negative value. That's why we have written this thing. Okay, clear? So this will be out positive. Clear? Okay. Now what? Now what is happening? Let me just see. Okay, that's why you will have f dash x is positive. Okay. Now, okay, clear? Okay. Okay. So now for the third, if you want to see the what option, the C option, 0 to pi. So 0 to pi, in 0 to pi, this will be what? At 0 to pi, cos is increasing. This is also positive value. So this is positive, this is positive, the sum will also be positive. So this means what? This means you will have what? You will have the whole thing positive. This means increasing function. So now the option D, let us see. So none of these. This means A option, B option and C option, everything gives me is increasing. But I want to be what? Such interval that in that interval I want my function to be decreasing. So this means option D will be correct. Hence none of the option given above is correct. Okay. I hope it is clear to you. Let us move to the next problem, problem number 14. So your function is given like this, x square plus ax plus 1. You have to find the value of a of this function, and a is this, the coefficient of x, where the extra information is given to you that your function is increasing in this interval, closed interval 1 to 2. So how you can get your a value? Quite simple, use the concept. So first of all, what will be your f prime will be 2x plus a. Okay, and you know in this interval it is increasing. Okay, this means fx is positive in this open interval 1 to 2. This means what? This means put f prime x is 0 to, sorry, strictly greater than 0. This means 2x plus a is strictly greater than 0. This means 2x is greater than minus a. This means x is greater than minus a by 2. You know x belongs to where 1 to 2. So put that. So x belongs to 1 to 2, this means minus a also belongs to 1 to 2. Yes, minus a also going to belongs to 1 to 2. This means what? This means you will have that minus a belongs to 2 to 4. Okay, so this will give you what? This will give you thus the least value of a for f to be increasing on this interval given by this thing. Okay. Okay, so as you can see, for what value? So we have many values for a. So one value is this, that the least value, as you can see. Or if you want to find the whole list, the list will be what? The list will be, as you can see, what will be your list? As x belongs to this, x must be greater than minus a by 2. And you know, x will be less than 2 and greater than 1. Okay, x will be less than 2 and greater than 1. Simple. So this means, what can you say about is that least value of a, if you want to find the least value, that means you have to compare with this thing when x is equals to 1. So this means when minus a by 2 is equals to 1, this means what? That a will be minus of 2. So the least value of a for f to be increasing will be minus 2. Okay, least value. The other value can also work. Okay, clear? Okay. Now 15th problem says let I be any interval. Okay, interval disjoint from -1 to 1. Prove that f is given by is increasing on I. Okay, this means that first of all find the derivative. Derivative will be 1 minus 1 by x square. Okay, now you all know what? You all know. Okay, so this will be this. So from this, what you can say, if putting this f prime x is equals to 0, you will find your what? Critical point. So critical point will be plus minus 1. Now you have to verify at 3 intervals in between -1 to 1 and from 1 to infinity and minus infinity to 1. Okay, now from so let us first verify in -1 to 1 interval. In -1 to 1 interval, it will be positive, as you can see. Yes, what? Your f prime will be what? In -1 to 1 interval, this will be what? As you can see, this value will be greater than 1, and greater than 1 means it will be negative, as you can see. X square, if x belongs to -1 to 1, this means x square, yes, it will be positive but less than 1. This means 1 by x is greater than 1. I have already told you this. This value, this 1 by x square will be greater than 1. Okay, it is already written over here. So this means the whole thing will be negative. So negative means, as you can see, obviously we are not including 0. The 0 is excluded. So this means it is decreasing at -1 to 1. What about minus infinity to -1 and 1 to infinity? Observe that if x is less than -1, if s is less than -1, the square is strictly greater than 1. This means 1 minus 1 by x square will be positive. This means f dash x will be strictly greater than 0, and the same case will happen for 1 is less than x square. This means x square is still greater than 1. This means the same thing will follow. This means in both of these interval, my function is increasing. So this means, hence we have showed that f is strictly increasing in interval I, disjoint from what interval? In this interval, because in this interval what you are having is decreasing. What you are having your function as decreasing. Yes, as you can see the above thing. Okay, what you are facing in here as decreasing. Okay, clear? I hope that it is clear to you. So that's it for now. We have to end up our session here. Okay, so we will be back with more remaining problems, as we couldn't complete our exercise 6.2. So the remaining problem will be covered in the upcoming session. Okay, so thank you all.